This is just going to be a short lesson on completing the square. Now, this is a common phrase you hear in algebra, and it refers to a perfect square trinomial. And you may recall you get a perfect square trinomial by squaring a binomial. And we said the shortcut way for that was square this first term. That gave you x squared. Multiply these two terms together. This gave you 4x. Now double it. That would give you 8x. And then you square this term, 4, and that gives you a 16. So what we have here is a perfect square trinomial. Now, this is a good little tool for a number of things we do in algebra. And suppose they gave you this example here, and they said, using this as a base, complete the square. And the technique for it would be have it in standard form, put a parenthesis below it that you're going to square, and what would be in this first position here? Well, it would be x, because the rule is you square the x to get this. Now, how did we get this middle term? Well, we multiplied these two together and then doubled it. So there's where we got the 8. So if we want to undo the doubling, what would we do? Well, we would divide by 2. So we look at this term, and by the way, this is our b term, and we're trying to find what our c term is, and there's a 1 here that we don't write. That is our a term. So how do we find our b term? Once again, we take half of what we have. Well, we doubled it. Now we take half. So half of 10 is 5. And we use that middle sign there. This is going to be a plus. So now how do we get our c term? Well, we take this, we said, and we square it. So out of the start of a trinomial, by using this process of completing the square, we have gotten to x plus 5, the quantity squared. And this is a useful technique for our lessons. So we'll do a few examples here. And, you can anticipate we want to complete the square. They're giving us this. So the protocol is to make a set of parentheses that we're going to square. We know that our middle sign we can just put right there. This is going to be x. Now this is our b term. How do we find what goes here? Well, again, we multiplied these together and doubled it to get our b term. So we will take half of what is our b term and put that here. And then to get our c term now, this is going to be our c term here, and it'll always be plus. Square 6 and get 36. Okay, we have it in its form. Set of parentheses. The middle sign goes here. And we have x squared, so this is going to be x. Now, when we have a number like this and we're taking half of it, just divide it by 2. So that would be half of 7. 7 divided by 2. But now when we get our c term, we have to square this. So this will be 49 fourths. So these are now a perfect square trinomial. We've got to them by completing the square. Let's try one more here. Our middle sign now is negative, so x goes there. Half of this is 5 halves. Squaring 5 halves gives us our c term, which is 25 fourths. Okay. Now, where do we use this, just to complete this little short exercise? Well, we use it in a problem like this. Now, this is not factorable. We could use the quadratic formula, but we could also use completing the square. So the process would be, write this part out here. Let me erase that. X squared minus 7x. Now we take the original c term and move that to the other side of the equation. And over on the other side, it becomes a -2. Now, we want to complete the square because we want a new c term here. So we put our parentheses. In fact, we did this one already, but let's just do it again. Our sign goes there. This is an x. We take half of that, which is 7 halves. And now we square 7 halves, and we get 49 fourths. Now, up to before I added the 49 fourths, this was still an equation. Now, to keep it an equation, since I'm adding 49 fourths here, I have to add 49 fourths to the other side also. Now, since I want to be able to add these together or subtract them, I have to make this 2 as an equivalent fraction that has 4 as a denominator. Well, remember, this is 2 over 1. So if I multiply this 2 over 1 by 4 over 4, which is a 1, we're authorized to multiply anything by 1. This becomes 8 over 4. So I'm going to erase this part here now, and you can see where I got it from. 8 over 4. So we're going to do this subtraction, and this becomes 41 over 4. And now I have a binomial that's squared, and it equals this. Well, we said that if we want to get rid of something that's raised to the second power, and I'll even change colors here, if we took the square root of that, this will become just the radicand. But if we took the square root of this side, we have to take the square root of this side also. And to solve this, for x, I just transpose that, and this will become x equals a -7 halves plus or minus the square root. Now I can take the square root of 4, that's going to be 2, and I'm just left now with the square root of 41, and I have solved this equation, and there's no square there. Let me erase that part here. X equals a -7 halves plus or minus the square root of 41 halves. And another way to write that would be a negative 7 plus or minus the square root of 41 all over your common denominator, since it's 2. Okay, a little review. Lots of stuff going on here, but we're featuring this process, completing the square.